Hi, and welcome back to the shop. Today, a short video to answer a few questions. Mostly questions that stem from the last video where we looked at producing a small jig for my neighbor. He lives just over there. That's why I'm pointing in that general direction. So I produced those jigs for him, and well, many questions were raised mainly about sequence of operation. So we'll take a look at that. But before that, I'd like to mention sequence of operations. Planning a sequence of operations is very important if you want to become a productive machinist and a successful machinist, because, well, it increases your productivity and it reduces the amount of scrap that you're going to produce. In other words, you're not going to waste material and you're not going to waste time. But it is a skill that's learned over many years. But it's nice to sometimes get a little helping hand to get on our way and to maybe accelerate the learning process. And well, for that, I have a series of videos that I produced some years ago. So you may want to take some time and go take a look at those. It's very theoretical, but it's very important. And even if it's boring, well, it's worth trying to fight your way through it. Well, first series of questions that I'm going to talk about have to do with the V-blocks. And well, where did I get them? I made them. And they were a project that we did in our shop video projects to learn all kinds of things, from angular grinding to angular milling to squaring up blocks to surface grinding, and so on and so forth. I think I also used the shaper for most of this project. So it's something you can go and take a look at, and there's a link for that. But remember, you can buy all kinds of these, and you can make all kinds of these, but if you don't have the equipment right now because you're just starting out to produce this, well, remember, you can go and buy them. And they come in all shapes and sizes. Here's another set that I produced some years back, actually when I was an apprentice. So that's a lifetime ago. So very, very practical tools. The only thing that I'll mention, because the question was raised, what are these undercuts for? And what's the hole for? Now, I used this hole to fix the V-block onto the drill press table. That's practical. But I could have very well have used a finger clamp as well. Now that hole, oddly enough, was put in there by me. I decided to put it into the design when I drew the project because it just made it easy for the students to hold this block on an angle plate for the angular grinding. It was their first experience with angular grinding, and while you don't want to make things any more complicated than you have to in the beginning. So that's what that hole was there for, but it's practical to hold it down with a screw clamp of some sort. But these notches or reliefs on the side, well, it clears the threads so the threads stay clean. I don't get holes full of chips, but also it gives us space to put finger clamps onto if I need to clamp them down to a table. Now, the plans for these V-blocks, if you'd like to attempt the project, well, you can download them directly from my webpage, THATLAZYMACHINIST.com. You can see it right down there. And well, it's right there. You just click on the button and you'll get it. It's on the first page, and you can also download my course notes and the final exam if ever you want of that lazy machinist a certificate. Okay, so that's our V-block. Another question was, why didn't I drill the 1/8 of an inch hole through the part and then followed up with the larger hole? And that would have meant that I would have only had to center one end and surface that end once centered, and then flip the part over and surface the second end without having to center the part any better than just by eye. Now, most jobber drills have a point that isn't a point. It's actually, if we look at it closely here, a straight line, okay? That describes a 45-degree angle or close to that from one lip to the other. That edge is hard to get rid of because it's really the expression on the end of the drill of the web of the drill. In other words, if both sides hold together, it's because there's a certain amount of material in the center to keep them together. Now, that is nice, but there's something more with this chisel edge that's nice, and that is it provides resistance. Most of the force that we feel when we're trying to drill comes from that chisel edge because it doesn't cut, it just moves material towards the both cutting lips. Now, I'm not going to go greatly into detail about this because again, we have a video that talks specifically about how twist drills work. Why do they cut the way they do and all the different parts of the twist drill. Why are they all important? But needless to say that that's important because if I have no resistance when I'm cutting, well, this drill we want to jam into the hole more than cut a nice chip. We can see that happening when a twist drill exits the bottom of a part because all of a sudden I'm still cutting, but I have no resistance coming from the chisel edge and the part really wants to pull through. So we can see that the chisel edge is important, but it gives us, or it is a problem in that if I'm going to pre-drill a hole, well, the hole that I pre-drill can't be larger than the chisel edge of the next drill that I choose. And that's the problem with my 4 holes. None of my 4 holes have a chisel edge wider than the pilot hole, and that means that when I use them, there'll be little or no resistance to penetration. And well, that is a problem. And that's not the only problem with drilling the 1/8 hole first. The other problem has to do with the flutes. The helical angle of the flutes on most jobber drill bits are at an angle that makes it difficult to drill in a continuous fashion more than 3 or 4 times the diameter of the drill. And that's particularly true with these small diameter drills. In order to avoid clogging the drill bit's flutes, you're going to want to use a peck drilling cycle. That means cut, retract, to clear the chips. And by the time you get about halfway down the drill's flutes, you're going to want to be pecking quite often. You're going to want to drill, retract, drill, retract. The amount of time that the drill can stay in the bottom of the hole is inversely proportional to the depth of the hole. So the deeper you go, the less you can drill for a length of time before you have to pull it out. And that, well, wastes a lot of time. And there is the problem of wandering. So when you drill a hole, you always want to drill it as least deep as possible. Let's put it this way. So if I drill this all the way through, well, obviously I'm going to be drilling almost the full length of my flutes, and that could be a problem. So I preferred to do it the way that I did. What about the reverse? And that is the other suggestion that many of you made. What if I started with the larger hole and then I drilled the smaller one? Now this is obviously an exaggeration because our largest hole, well, was this big, and this was our 1/8 hole. So we see there that there is quite a difference. The problem here also has to do with the chisel edge. The chisel edge is basically a flat, it's a straight line, and if you look at the end, it is a flat almost when you look at it completely sideways. And the next drill will be much smaller than that. So what is that analog to? What does that seem to be like? What seems to be like drilling a hole into a flat surface without any spot or center punching being done. So you need to spot drill or center drill if you want your normal jobber drills with this chisel edge to track properly at the very start. So that is a problem. And it doesn't work with any of the drills because all the drills larger than the 1/8 have a chisel edge on the tip that's larger than the chisel edge on my 1/8 of an inch drill. So that means that it's always going to want to wander regardless, or as I say, irregardless. I know that gets on many people's nerves, so I'll just say regardless of the next drill coming. If it's larger, you have a problem. We can work around that problem, and that would be a good technique if one condition is met. And that is that the drills that you use are split point drills. Split point drills aren't sharpened the same way, and they come much more to a point than to a chisel edge. That means that split point drills will track a lot better right from the get-go. They're pretty well self-centering. You don't need to spot drill unless you're not sure that the surface of your part is really nice. So why not only use this type? Well, there's a reason there as well. And that is that they are much more difficult to sharpen. I mean, once you have your split point drill and you've worn it on its tip, you're going to want to back the drill down when you sharpen it. And once you do that, if you're sharpening by hand, you're basically going to end up with your regular chisel edge, because this split point is really hard to do by hand. Not impossible, but it's out of reach of most garage machinists. So that is why I showed the other way, and that is why I recommend not to do it in that order. Large hole first, small hole after, always cutting in the same direction, because your drill's going to wander. So until we meet again, well, have fun. Be safe. It's so very important. And happy machining.